What makes a substance hazardous? Is it the ability to destroy things by burning them, blowing them up, or eating them away? Or its potential for disrupting the normal functions of the human body, causing healthy cells to turn cancerous, or toxins to build up in the blood? The answer to both questions is yes. This is why it's so important for hazardous materials labels to provide clear, accurate information about a substance, often when seconds count. In this program, we will discuss several of the most common hazmat labeling systems that are in use today, and describe how you can use them to help you handle hazardous materials safely. One of the best ways to provide people with information about a hazardous material is through a container label. In fact, labeling containers is so important that OSHA, the Department of Transportation, and the Environmental Protection Agency, EPA, have all established labeling requirements for the materials that they regulate. And as the world has changed, many of these requirements have evolved too. One of the biggest changes has been OSHA's integration of the Globally Harmonized System for the Classification and Labeling of Chemicals, the GHS, into the Hazard Communication Standard. According to the standard, GHS labels must be used on manufacturers' and distributors' chemical containers, as well as on any containers that are used for transport. And to keep workers safe, even if they don't work with original containers of hazardous chemicals, OSHA requires that warning labels also appear on all in-house chemical storage containers. But OSHA doesn't stop there. It also requires companies that use hazmats to attach warning labels to any other types of containers, such as mixing vats or secondary containers like buckets or spray bottles that hazardous substances are transferred into. At a minimum, these labels must include the name of the hazardous chemical, associated hazard warnings, and the name, address, and telephone number of the manufacturer, importer, or distributor of the chemical. While OSHA is concerned about all types of hazardous chemicals, the focus of the Environmental Protection Agency, the EPA, is on hazardous waste. Any containers of hazmats that are being disposed of must have labels that identify each of the materials in the containers, no matter how thoroughly they are blended together. EPA hazardous waste labels must also include the originating company's name, address, and telephone number. As you would expect, the third government agency that requires hazmats to be labeled, the Department of Transportation, is concerned about materials that are being transported. So the DOT's labeling requirements apply to the containers of hazardous materials that are being moved from place to place, as well as the conveyances that move them. This can include trucks, planes, ships, even pipelines. While the labeling requirements of these three government agencies have some significant differences, they all have some things in common as well. First, all of the agencies require that labels be firmly attached to their containers. However, the term container is defined fairly broadly by each group and can include drums, barrels, boxes, bottles, cylinders, process vats, and tanks. Second, all of the agencies require that hazardous materials labels be displayed prominently so that they are easily noticed by anyone working with a container. And third, the information on all labels must be legible, which is especially important if the label contains handwritten information or the container is in an environment where the label could be smeared or otherwise damaged. Because hazard information can be shown in a number of ways, over the years, several different types of hazardous materials labeling systems have been developed, some by the agencies themselves, others by private industry, for several different purposes. The systems that are used most often include the Globally Harmonized System, GHS, Department of Transportation, DOT, Hazard Class Labels, Hazardous Materials Identification System, HMIS labels, National Fire Prevention Association, NFPA labels, and EPA hazardous waste labels. People who handle hazardous materials need to be able to get information about hazmats quickly and clearly in order to work with them safely, no matter where those people are or what language they speak. To accomplish this, the Occupational Safety and Health Administration, OSHA, needed a uniform system for presenting that information on hazardous materials container labels under the HazCom standard. They found it in the Globally Harmonized System of Classification and Labeling of Chemicals created by the United Nations. The Globally Harmonized System, GHS, helps people anywhere in the world get accurate information about hazardous materials with just a quick look. To do this, the system standardizes how materials are classified, how their hazards and safety precautions are described, and how this information is presented, so that all workers can find the information they need even under pressure. GHS begins this process of standardizing hazmat information by dividing materials into hazard classes that are represented by 9 pictograms. These images allow a container label to communicate hazard information at a glance. GHS container labels also use text elements to convey 5 specific types of information about a material, including its name, a signal word, a hazard statement, precautionary information, and the name and contact information of its supplier. The Globally Harmonized System also recommends how these elements should be positioned on the label, so a worker always knows just where to look to find the information that they want. GHS-compliant labels must be displayed on all hazmat containers, except those that are used as in-house containers, that is, secondary containers that will never leave the facility. While in-house labels do not have to follow the GHS format, they do have to display all of the information that is required by the system. DOT labels and placards are used on materials that are transported. They are diamond-shaped, and you will see them on all sorts of containers, as well as on the sides of trucks, trains, and other conveyances that are used to carry hazmats from one place to another. In order to ensure their visibility, DOT labels have strict design requirements. The labels on chemical containers themselves must never be smaller than 3.9 inches, 100 millimeters on each side. This allows you to identify the labels from 10 to 15 feet away. The placards that are used on trucks and other vehicles must be significantly larger, since they are most often viewed while they are in motion and from a distance. So the DOT requires that placards measure at least 9.84 inches, 250 millimeters on each side. Some DOT labels and placards display symbols in the top half of their diamonds. In many cases, these pictograms are the same ones that were created for the UN's Globally Harmonized System of Classification and Labeling of Chemicals to designate various hazard classes. What you find underneath these symbols, in the bottom half of DOT labels, is the material's hazard class number. For quick identification, the DOT has grouped hazardous materials into 9 classes, each representing a specific type of hazard. These classes are identified by number from 1 to 9. Class 1 is made up of explosives. This category contains anything that can detonate, from shock-sensitive materials to substances that will only explode under specific conditions, such as extreme heat. Class 2 consists of all gases, whether they are flammable, non-flammable, toxic, or inert. Class 3 is comprised of flammable liquids, specifically those with flash points below 141 degrees Fahrenheit, 60 degrees Celsius. The flash point of a substance is the lowest temperature at which it can readily catch fire. The lower its flash point, the more flammable the material. DOT Hazard Class 4 is made up of flammable solids. These have ignition characteristics similar to flammable liquids in Class 3. Class 4 also includes spontaneously combustible and water-reactive materials. Class 5 covers oxidizers and organic peroxides. Both of these types of substances can enrich the oxygen content of other substances, making normally safe materials flammable. Class 6 includes all poisonous substances. The DOT defines poisonous very broadly and includes toxic and infectious materials in this class. Hazard Class 7 encompasses all radioactive materials. If a substance emits alpha, beta, or gamma radiation, it belongs in this category. Class 8 contains corrosives, defined by the DOT as liquids or solids that cause visible destruction or irreversible alterations to skin tissue. Class 9 includes any substance that doesn't clearly fit into one of the other 8 categories, and as a result is titled Miscellaneous Hazardous Materials. In addition to their symbols and numbers, DOT labels also employ a color coding scheme. If a label is too far away to be read, color coding lets emergency responders know which DOT hazard class the material belongs to. Red represents flammables and combustibles. Orange stands for explosives. Yellow indicates oxidizers and oxygen. Yellow, black, and white on the same label designate radioactive materials. A half-black, half-white diamond identifies corrosives. White signifies toxins, poisons, and infectious substances. Blue denotes water-reactive chemicals. And green indicates non-flammable substances. When this color coding is used in conjunction with hazard class numbers and GHS hazard symbols, the result is an easy-to-use comprehensive labeling system that can identify any sort of substance. While the DOT labeling system is used primarily in North America, some DOT labels do have one feature that is recognized worldwide: United Nations UN identification numbers. Under this international identification system, every substance is assigned a unique 4-digit number. For example, the UN number for gasoline is 1203. Because they are reasonably specific, in a hazardous materials incident, UN numbers can be a crucial source of information for first responders and help hazmat crews to bring events quickly under control. In fact, because of this, the yellow section of the North American Emergency Response Guidebook is arranged according to UN number. While DOT labels deal with transportation issues, the labels in the Hazardous Materials Identification System address OSHA's in-house labeling requirements for the end users of hazardous chemicals. The goal of HMIS labels is to provide information that can help to prevent accidents in warehouses, factories, laboratories, and other workplaces. Over time, various versions of the system have been developed, but the most common groups hazards into 3 color-coded categories: blue for health, red for flammability, and yellow or orange, which designate reactivity or physical hazards. Numbers are used within each category to indicate the degree of the hazard. In the health category, 4 indicates deadly. Even the slightest exposure to this substance can be life-threatening. 3 indicates extreme danger. Serious injury would result from exposure to this substance. 2 indicates dangerous. Exposure to this substance can be hazardous to your health. 1 indicates slight hazard. Irritation or minor injury would result from exposure to this substance. And 0 indicates no hazard. Exposure to this substance poses no significant risk to your health. In the flammability category, 4 identifies materials that have flash points below 73 degrees Fahrenheit and boiling points below 100 degrees Fahrenheit. They will ignite very easily. 3 identifies substances with flash points between 73 degrees Fahrenheit and 100 degrees Fahrenheit. They also ignite fairly easily. 2 identifies chemicals with flash points between 100 and 200 degrees Fahrenheit. Materials that are harder to burn. 1 identifies materials with flash points above 200 degrees Fahrenheit, the materials that are hardest to ignite. And 0 identifies substances that will not burn at all. In the reactivity and physical hazards category, 4 indicates that the substance is capable of exploding at normal temperatures and pressures. 3 indicates that the material can be detonated by a strong initiating source, such as heat, shock, or water. 2 indicates that the substance is unstable and is capable of violent chemical changes at normal or elevated temperatures and pressures. 1 indicates that the chemical is normally stable, but may become unstable at elevated temperatures and pressures or when mixed with water. And 0 indicates that the substance will not react with water, polymerize, decompose, or detonate under any conditions. Using this combination of colors and numbers, a good picture of the hazards that are associated with a substance can be formed. For example, an HMIS label for gasoline would have a 1 in the blue space, since gasoline is only a slight health hazard, a 3 in the red space, because it can ignite at below 100 degrees Fahrenheit and is a flammability hazard, and a 0 in the yellow space, since it won't detonate. In addition to these hazard numbers, the personal protective equipment PPE that should be worn when handling the substance is identified at the bottom of every HMIS label by the capital letters A through K. By consulting a chart or a wallet card that shows what each letter stands for, it's easy to see what level of protection is needed. For instance, the capital letter C indicates that safety glasses, gloves, and a synthetic apron should be worn when working with the material. If the personal protection column is marked with an X, special handling is required, in which case you will need to get additional information from the material's SDS or your supervisor. Some variations of the HMIS system use pictograms instead of letters to show what PPE should be worn, which makes it even easier to determine what you need. Certain hazardous substances may also require target organ information that indicates which organs can be affected by the substance. In the HMIS system, this is typically provided as text at the bottom of the label. You also need to look for an asterisk in the health hazard section of an HMIS label. This indicates that the substance is a chronic health hazard and that repeated exposure to it could cause health problems. If you encounter labels that contain any of these special warnings, consult the material's SDS for more information or ask your supervisor for instructions as to how to work with the substance safely. NFPA labels are another system that is frequently used where chemicals are worked with or stored. Where they differ from other types of labels is that their focus is specifically on information that is important when a chemical is involved in a fire, such as whether it reacts with water. NFPA labels are diamond-shaped and use 4 color-coded sections to convey their hazard information. The colors red, yellow, blue, and white each represent a specific type of hazard. NFPA labels use the numbers 0 through 4 to indicate the severity of the hazards in each color category. 0 indicates that a material is non-hazardous, while 4 warns that the material is extremely hazardous. The 4 color-coded sections within the NFPA diamond are diamond-shaped as well. The red area at the top of the label shows the material's degree of flammability, of particular interest for a fire control agency such as the NFPA. On the right, the yellow section indicates how stable the substance is. The blue quadrant on the left tells you how likely the substance is to cause health problems. And at the bottom of the NFPA label, the white area uses icons to indicate if the substance is a special hazard. 3 of the most frequently seen special hazard icons are for radioactive materials, indicated by the international symbol for radioactivity. Water-reactive materials, identified by the capital letter W with a line drawn through it. And oxidizers, designated by the capital letters OX. Water reactives and oxidizers present particular fire control issues. If a water-reactive chemical comes into contact with water, it will actually cause a fire or explosion, while oxidizing chemicals release oxygen into the atmosphere, making everything in the area more flammable than normal. By including information about these substances on their labels, the NFPA makes workers and firefighters aware that these materials pose special fire hazards, so that they can be approached cautiously and handled appropriately. Under federal law, EPA-approved hazardous waste labels must be attached to all containers of discarded chemicals that are harmful to human health or the environment. The labels must identify the contents of the waste containers and include the originating company's name, address, and telephone number. An EPA waste identification number must be obtained for each discarded substance. These are assigned by the EPA based on the types of materials in the container, the facility it is coming from, and the date it is being shipped. This identifier must then be entered on the label, along with the waste's DOT proper shipping name, and if it has one, its UN number. To prevent confusion, all other labels must be removed from the container before a hazardous waste label is attached. If a container holds a mixture of 2 or more discarded chemicals, a workplace accumulation label must also be attached. These accumulation labels must list the individual materials that make up the waste. If a container is leaking and has to be placed into an overpacked drum, a hazardous waste label must be placed on that drum as well. Some states use their own hazardous waste labels instead of the federal labels, so you may need to check with your state's Department of Environmental Resources to determine if you should use a state label. And you should never put any hazmat waste label on a container that does not hold waste. On the other hand, if you find a chemical container that is unlabeled, you must treat it as if it contains hazardous materials or waste until it is determined otherwise. This means that everyone should stay away from the container, and your supervisor or safety manager should be informed immediately.
All right, why don't we back off from it a little bit? We'll treat the whole area.
The most hazardous materials you'll ever encounter are typically the ones you don't know anything about. So hazardous materials labels are there to tell you what a material is, what its hazards are, and what you need to do to handle it safely. Let's review. Always look for warning labels on any containers you encounter. Read all labels carefully and pay attention to the information they contain. When a label recommends wearing personal protective equipment, do it. If you're not sure what a label means, ask your supervisor. If you are responsible for labeling containers, make sure that it's done correctly. We all love a mystery, but not when it can hurt us. And unidentified hazmats can do just that. But now that you understand what information hazardous labels contain and how to read them, you can help to make sure that hazmats are handled safely in your workplace.